Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet problems 41 to 50 on proportions. So consider a 90% confidence interval to estimate a population proportion that is constructed from a sample proportion of 66%. So they're telling us right away that p hat equals 0.66. If the width of the interval is 10%, what is the margin of error? Well, there's a shortcut way to doing that. Because this is the total width, I could just divide it by 2, and I would get my answer as being 0.05. But I want you to consider what this actually looks like. We know that it's our intervals p hat plus or minus the margin of error. That's the formula. All right, well, if we know that p hat is 66, 66 plus or minus some value. Well, how much are we adding? Well, if I add 5, 0.66 plus 5, that takes me to 71. And if I take 0.66 and I subtract 5, that takes me to 61. And then I subtract those two values, and that's where the 0.1 is, because my interval is actually, in this case, a lower bound of 0.61, an upper bound of 0.71. So this would be my lower, this would be my upper, and those two subtracted gives me 10, and that's the width. So in this case, our answer choice of 41 happens to be B. For a one sample test for a population proportion and sample size n, why is it necessary that NP and NP are both greater than 10? This is my normality condition. Basically, the sample must be large enough to say that the distribution is approximately normal. So the sample size must be large enough to support an assumption of the distribution of the population. No, we don't care about the population. We care about the sample. The sample size must be large enough to support an assumption that the distribution of the sample is approximately normal. I like that. But let's keep going, because sometimes there's a better choice. The sample size must be large enough to support an assumption that the sampling distribution, ooh, much better. Because here's the difference. The distribution of the sample should be like the population. We're talking about the sampling distribution of these sample proportions, and that should be approximately normal. All right? Be careful about the wording. We're looking for sampling distribution. 43. A school librarian wanted to estimate the proportion of students in school who had read a certain book. The librarian sampled 50 students from the senior English class, and 35 of the sample had read the book. Have the conditions for creating a confidence interval for the population been met? Well, um, we don't know if it was random. Um, and that right there creates a problem, and that's actually one of the answer choices. No, because the sample is not selected using a random method. The other thing is we don't know what the population size is, so we couldn't know that there's more than enough students. But um, it doesn't anywhere say that how that it was that randomness was employed. No randomness, not doesn't work. 44. A recent study on the way that people talk indicated with 95% confidence that between 35 and 41% of all adults find the word whatever to be the most annoying word in the conversation. Based on the confidence interval, which of the following claims is supported? That between 35 and 41%. So let's make that up. Let's make that interval. We have a lower bound of 0.35. We have an upper bound of 0.41. So there's my lower, this is my upper. And with that said, we know where the middle is because we can average the two. A recent study on the way people talk indicated with 50 I guess there isn't an A. 44B, more than 30% of all adults find the word whatever to be the most annoying word. Well, I think that's true. Why? Because 35% and 41% are buy into that. More than 45% of all adults find whatever to be no, not more than 45%. All right. More than half of all adults no. We don't get that high. At least 95% no. The only statement that's reasonably true is B, and A is obviously a typo. 45. A social scientist believed that less than 30% of adults in the United States watch 15 or fewer hours of television per week. To test the belief, the science randomly selected 1,250 adults in the U.S. The sample proportion of adults who watched 15 or fewer hours of television per week was 0.28. And the resulting hypothesis had a p-value of 0.061. The computation of the p-value assumes which of the following is true. Well, p-value is the probability that the null hypothesis is true. So in this case, the claim is that 30. So HO would be the p-value equals 0.30. So it's assuming that this is true. All right. So the population proportion who watch 15 or fewer hours per week is 0.30. Don't use the sample. You have to use the actual population claim or what was thought to be the case, which happened to be B. 46. Biologists were studying the proportion of cats that had spotted markings on their fur in two populations of cats, C and F. An independent random sample of cats was taken from each population, and the difference between the sample proportions of cats with spotted markings C minus F was 0.62. Under the assumption that all the conditions were met, a hypothesis test was conducted with the alternative hypothesis that the population proportion are not equal. The p-value of the test was 0.01. Which of the following is the correct interpretation of the p-value? All right. So the cut would be that they're not equal. So if the alternative, if HA is not equal, that means our null would be that they were equal and there was no difference. So the p-value, excuse me, still fighting a cold. If the proportion of all cats with spotted markings is the same for both populations, the probability of observing a sample difference of at least 0.62 or more, most negative 0.62, is 0.01. So if there was no difference, if it's the same, equal is the same. So there's our equal. There's our p-value. And it's a not equal. So we have to look at it as a two-tail, which would be as low as the 0.62 and or 0.62 and negative 0.62. Because remember, you have to make it two-tail if you're working with a not equal. So we have to consider the low and high. Perhaps I should draw a picture for that. We should be centered on 0. Because basically it's saying P1 minus P2 is centered at 0. And it's a not equal, so we're going to have two tails. And we have a we got a difference of 0.61. So we're up here, but we also have to consider the difference that it is negative 0.61 because it's two-tailed. You have to assume for both. You have to adjust for both. Consider a hypothesis test in which the significance level is alpha equal 0.05 and the power of the test is 0.65. What is the probability of making a type 2 error? Well, power equals 1 minus beta, and beta is the probability of a type 2 error. So the power of the test is 0.65 equals 1 minus beta. If I subtract 1 from both sides, I end up with negative 0.35 equals negative beta. Those two become positive, and I end up with 47 being D. And there we go. 48. If all else is constant, which of the following would result in a decrease of the probability of a type 2 error? So remember, type 2 is fail to reject HO. All right. So decrease the probability. The true parameter is closer to the null. No, we want them far apart. Once again, I've talked about this before. If we had Z equals P hat minus P over P times 1 minus P over N, the further they are apart, the more likely I am to reject. So I need them far apart. If they're close together, I'm more likely to fail to reject. And so I need to decrease it, not increase it. The sample size is increased. If I increase the sample size, this part in here gets small. If this gets small, Z is going to get big, which means I'm going to get further and further out in the tail. The farther out I am in the tail, the more likely I am to reject. All right. Significance level. As alpha goes down, beta goes up, more likely to commit. All right. Standard error. This is the standard error right here. If this gets increased, um, if that gets increased, then I'm dividing by a bigger number, which makes this smaller. Dividing by a bigger number makes this smaller, makes my Z smaller. And then, of course, that's just false. All right. Then 49. Which of the following is the best interpretation of the power of a significance test? Power is the probability of correctly rejecting a false null. All right. So correctly rejecting a false null. To do that, I have to detect a difference. So I have to detect an effect. So that gets rid of these. If the effect actually exists. All right. If it actually exists. So I detected it because it exists. And if it exists, I should detect it. I do detect it. If all else is constant, which of the following results in an increase in the probability of a type 2 error? All right. So increasing a type 2, remember type 2 is fail to reject HO. All right. And if power goes down, beta goes up. Also, if alpha goes down, beta goes up. So if the significance levels increase, no, they move opposite directions. That would drive it down. And we're looking to increase type 2. The standard error is decreased. Okay, so Z equals P hat minus P over P minus P times 1 minus P over N. This right here is my standard error. If I make this a smaller number, let's just say I went from 10 to 1. If I'm dividing by a smaller number, that means my Z gets big. As Z gets big, I'm more likely to decrease. I'm more likely to reject. Why? Because if this is 0, 1, 2, 3, -1, -2, -3, if I'm going out into this tail or this tail, I'm more likely to reject. So the further I'm into the tails, the more likely I am to reject. So decreasing the standard error does make it easier to reject. Let's continue to go. So more likely to reject. So, and I'm looking to increase error. That makes it easier. This made it easier to reject, and I need to make it easier to fail to reject. That's false. The true parameter is closer to the null. If these are close together, it becomes hard to reject. If it's hard to reject, I might make a mistake. Let's put it this way. If I claimed the test average was 67, if I claimed the test average was 70%, if it was really 68%, that's pretty close. You might not detect it. But if it was 50%, you'd probably detect it really easily. So the farther it away the farther the real reality is from the claim, the easier it is to reject. So you might want to write that down. The farther reality is from the claim, the easier it is to reject. All right, this concludes this video. Answer for 50 was D. Thanks for watching and hope to see you on the next one.